Hello guys, I'm going to show you the full solution of the exam paper in 2022 Higher Level Physics Paper 1 of Time Zone 2. And no bullshits, let's go! In question 1, you're given with some information of the radius of a circle. And based on the information, you are going to calculate the value and absolute uncertainty of its area. So let's make a drawing first. Firstly, you have a circle over here, and then the radius here, it's equals to 10.0 plus or minus 0.5 in centimeter. Then the area of a circle is pi r square, which means the uncertainty they are related in this way. Absolute uncertainty over area. The absolute uncertainty of area over the measured value of area is equal to the absolute uncertainty of pi divided by pi, and then the absolute uncertainty of r square over r square. Next, you can tell the absolute uncertainty of pi should be 0 because it is not a measurement. Then we can simplify the equation to this one. And next, we don't know the absolute uncertainty of r squared. However, we do know the absolute uncertainty of r. Then we can make use of the formula sheets and make the square out of the fraction. Now it's a multiplication. And therefore, the required uncertainty should be 2 times of 0.5 over 10. The fractional uncertainty of area should therefore be 0.1. And checking all the options on A, B, C, or D, there is only one of them giving you a ratio of 0.1, which is 31 over 314, which is very close to 0.1. We pick D here. In question 2, you are given with two sets of data. They are P and Q. And in each set of data, you can see a maximum gradient as well as a minimum gradient. First, let's extend this line for both the maximum gradient and minimum gradients for both graphs. And let's take a look at Q first. In Q, the gradient could be very steep and much less steep as well. The range is very wide. There are lots of uncertainty here, which means the uncertainty of the gradient should be greater for Q. Meanwhile, on P, the range of possible gradient is much more narrow. Okay. Next, we check their y-intercept. Because this is an experiment trying to confirm their proportionality between x and y. So we expect the xy axis, they are passing through the origin. And you can see here, Q could possibly pass through the origin. But P, it is not passing through the origin. So there is a greater systematic error going in P, because it can't pass through the origin. Probably the setup was wrong at first. Then we choose C here. In question 3, we have an object started from rest sliding down a frictionless inclined plane. And this object slides by 1 meter in the first second, which means the first second journey was this red arrow. And the following second, which means the second should be somehow like this one. The box will therefore be at a position in blue. Our target is trying to get the new displacement in the second only, in the next second. It's time to create a Suvet table to determine the correct Suvet equation. Let's get the red Suvet table prepared on the left. The displacement here is 1 meter. Initial velocity was 0 as it was started from rest. And the final velocity, which is at the red and blue transition here, the final velocity is unknown. And note that it is the red final velocity. At the same time, it is the blue initial velocity. It's practically the same point and the same velocity. Acceleration A should be the same throughout the whole journey because the gradient of the ramp is always the same. It's the same A throughout the whole red and blue journey. Time is 1 second for the red parts. So let's take a look at S equals ut plus half at squared. And the numbers are plugged in so that we can get the acceleration A. A is therefore 2 meter per second square. And let's update our Suvat table here. 2 meter per second square. With this extra information, we can get the red final velocity using V equals to U plus AT. U is 0, A is 2, time is 1 second, so the final velocity of the red journey should be 2 meter per second. And it is 2 meter per second here. Let's create the blue Suvat table on the right. The blue S is unknown. The U is the same as the previous one, which is 2 meter per second. V is unknown. A is 2 meter per second. T is 1 second as well. Then we have a equation of S equals to ut plus half at squared again. S is unknown, U is 2 times 1, and then half times acceleration A times time squared. The displacement traveled in the second is 3 meters. Answer is C. Question 4. A ball is thrown vertically up and then return to its same height, the initial height, after time equals to capital T. And then, for the same motion, if we stop the clock at an earlier time, then it will be time equals to variable T, and the height of the blue arrow here should be H. Which means we have two sets of Suvat table for the same journey. The red one and the blue one. Let's focus on the red one first. For the red one, we can start with S equals to ut plus half at squared. And throughout this whole question, let's take upward, be positive. So for the red Suvat equation, we have S being 0 because it returns to the hand. U is unknown, T is capital T. Acceleration is G in negative because it's pointing downward acceleration. T is capital T squared. And then we can rearrange to make U be the subject. U is half G capital T. And let's pick this information to the blue journey. For the blue one, S is unknown H, U is half GT, time is small t, acceleration A is negative G again, time is small t squared. So after rearranging, you should get H is half G T big T minus small t, which means the answer is D. In question 5, we have one big tower, and from this tower, we're going to drop two balls. One of the ball is a solid metal ball, which means it has a great mass. Let's label this one as big M. On the other side, you have a hollow metal ball. This is the same size and the same shape. So it has a lower mass, small m. And these two balls, they are both released from rest. So they are both starting from 0 velocity. And the bigger mass gives you a bigger weight. The smaller mass gives you a smaller weight. Therefore, their terminal velocity will be different as well. For the solid metal ball, it requires a greater drag. in order to reach the terminal velocity, but the hollow ball, because of its lighter weight, it will give a required drag being lighter as well. For a faster object, there should be a greater drag, which means for the hollow metal ball, there is a greater terminal velocity. So when you pick the option A, B, C, D, you are going to pick a new hollow metal ball with a lower terminal velocity. Therefore, A and B, they are wrong. How about C and D? What are their differences? Their differences are the initial gradient. You can check that the initial gradient of the dotted line is this one. Meanwhile, the initial gradient is indicating the initial acceleration. The acceleration is the gradient, and its acceleration should be 9.81, no matter is it hollow or solid, which means they should give you the same initial gradient, and C is the answer. In question 6, we have a rocket. It is just being launched vertically from the Earth's surface. And this single ball is representing the rockets. F1 and F2 are the forces acting on the rocket. They are both acting on the rocket. So F2 is acting downward, which means this one is the weight. And it is acted by the Earth on the rocket. Similarly, for F1, it is probably the propulsion. And such propulsion is acted by the gas on the rocket. Then, according to the Newton's third law, which must be the same magnitude but opposite direction, moreover, it's A exerting on B as well as B exerting on A. So their action and reaction pair for F2, it should be acted by rockets on the Earth. Moreover, it must be a weight as well. Which description going as the blue description over here? It is a gravitational force, and it is acting on the Earth. On the Earth. So option B and D, they sound possible. How about the pair of F1? It should be another propulsion, but this propulsion is acted by the rocket on the gas. It is a propulsion acting on the gas. So the correct answer is B. In question 7, we have a trolley on a roller, which is rolling along the ground freely, which means there is no friction on the ground. But the surface between the book and the table here, it is rough. Therefore, there is friction acting on the book, on the small m. Let's study the forces acting on the book. There should be a weight acting downward. There should be a normal reaction acting upward. And because the force acting on the trolley is going to the right, which means the system is accelerating to the right, finally the force should be acting to the right as well. The frictional force acting on book is going to the right. This system must follow the Newton's second law, which is net force equals to ma. Now the net force on the small m is the frictional force. And the frictional force is mu r, which is mu mg as well. And it gives the acceleration being mu g, b. In question 8, we have two identical springs. And these two identical springs, they are attached to two different masses, x and y. Their compression are both 0.1 meter. But because of their masses are different, their speed in the end will be different. The mass of x is 1 kilogram. The mass of Y is 0.25 kilogram. So let's calculate the energy conversion here. It is the elastic energy going to kinetic energy. Elastic energy is half k delta x squared, and it is converted to half mv squared. So we have half 100, 0.1 squared equals to half 1 and v squared. V shall be 1 meter per second for x. For y, there is a similar calculation. Let's set up the symbols equation like this one. Then we substitute all the numbers that you are given with. And lastly is once again another rearrangement, and you will get the answer. Square root of 4, therefore v is 2 meter per second. The answer is C. In question 9, you are going to manipulate some equations given in your formula sheets in order to deduce a correct relationship between these symbols. And the formulae being provided are as follows. All these equations you can see here, they are obeying ideal gas law. And you can see that Kb is identical to R over Na. Let's continue the equation of PV equals nRT like here. N could be replaced with capital N over Na times R times T, and then let's rearrange them to make N times R over Na times T. Meanwhile, R over Na is the same as these two, which means we can replace nRT going as N times kBT. So the correct answer is A. In question 10, we're going to identify the correct assumption of molecular kinetic model of ideal gas. Option A, it suggests that the work done on a system is equal to the change in kinetic energy of the system. How do we change the kinetic energy of a system? There are two ways to do so. Firstly, just like the question suggests, you can apply a work done to the system. Let's say this is a syringe with a movable piston. Then the piston is attached to a controller which may go up and down. And those gas particles, they may speed up or slow down. If the piston is being compressed, then work done is acting on the particles and they will move faster, which is the kinetic energy is increased. But this is not the only way to do so. Apart from providing work done to it, we can also put gas particle inside a fixed lid, a fixed piston here, but you can provide heat to it. Which means by providing work done or providing heat energy, the gas particle would gain kinetic energy. So A is wrong because there are two ways to increase the kinetic energy of the system. Option B, it suggests that the volume of the gas is the volume of the individual gas molecules adding up. Which means it suggests that here we have some gas particle and the volume of the gas, which means the whole volume of the container, is the sum of volume of individual molecules. Adding up all these molecules' volume together, it becomes the total volume. And this is wrong. The reason is, in assumption of molecular kinetic model of ideal gas, the volume of each tiny molecule is 0. Which means the pink volume should be 0 plus 0 plus 0 plus forever 0 is still 0. So B is wrong. Next one, C. C suggests that in the container, these molecules, they are going in a straight line, in a constant straight line until it hits a wall, then it bounces back. And these particles, they are not always going to the right. Some of them could be going downward. And similarly, once it hits a wall, it will bounce back. So it's a constant in a straight line, meanwhile it's random in direction. And they are all identical. C is the correct answer. Let's take a look at what's wrong with option D. In option D, all ideal gas particles, they have no intermolecular force and therefore they have zero potential energy. That's why D is wrong. In question 11, we have a cup of water starting from the room temperature and it's being placed in a freezer. It suggests that the specific heat capacity of the water is twice of that of the ice. So specific heat capacity of water is double of that of ice. And next, which one of the graph is a correct representation of the change in temperature with respect to the time? And you can see that it's always the same for the flat line. It's all identical, which means we can ignore these parts. What we should focus on is the gradients before turning into ice and after turning into ice. Gradients of the graph, which means it is the change in temperature over the change in time. And to get this ratio, which begins with the equation Q equals mc delta T. Q is the thermal energy and it is the power times the time, P times delta T. And here, let's rearrange to get the gradients. Delta temperature over delta time, P over mc. They share the same P according to the question, constant rate, same P. And it is the same amounts of water turning into ice, which means it has the same mass as well. Therefore, the gradient here is inversely proportional to the specific heat capacity. Let's take a look back over here. Water's specific heat capacity is double, which means water's gradient is half. And the correct answer should be B, because the water section is less steep than the ice section. In question 12, we take a look at a simple harmonic motion. The most important and the most fundamental condition for SHM is acceleration is proportional to the negative displacement from equilibrium point. And basically, from this condition, you can tell the answer. When A is large, x is large. When A is 0, x is 0. So which of the quantities of the motion could be simultaneously being 0? A and x. Acceleration and displacement from equilibrium point. B is the answer. Question 13, there are two graphs, graph M and graph N, but they're both describing a single wave. Because this is the graph, one of it is a variation with time, the other one is a variation with distance. The variation with time between P and Q, you can see one cycle. In one cycle, the corresponding time is known as the time period, which means P times Q is the time period. From R to S, it is another cycle, but this is a cycle in a graph of distance. So R to S, it is the wavelength. Speed of a wave is frequency times wavelength, and frequency is 1 over t times wavelength, which means the speed of the wave should be 1 over pq times rs. So the answer is C. In question 14, you are given with the refractive index of glass and the refractive index of water. Let's put these all together in the following table. This is the glass, this is water, and this is air. Their relative refractive index is 3 to 2 for glass to air, and 4 to 3 for water to air. So this could be simplified as glass, water, air. They are also in the ratio of 9 to 6 as well as 8 to 6. That's how we link them together, because right now you can tell the overall ratio of glass to water to air is equal to 9 to 8 to 6. That question asks for the critical angle between glass and water. Glass and water. So the answer should be 9 and 8. And there is only one option, which is 9 and 8. The answer is D. And if you want a further detail of why the answer is arcsine 8/9, let's take a look at the following derivation. For critical angle to happen, it's going as the Snell's law over here. Refractive index of water and glass going as the angle in glass and water. For total internal reflection to take place, it should be sine critical angle and then sine 90 degree. So it is 8/9 equals to sine critical angle. And that's how you get D. In question 15, we have a question in polarization. The polarization begins with an unpolarized light with this intensity at first, and the two, polarizer and analyzer, they were originally aligned in parallel, which means if there were 100% of intensity at first, then it will be 50% here and 50% over here. Because the original light, it was unpolarized, then half of the energy would pass through, and it is vertically polarized, which is in parallel with the transmission axis of the analyzer, and it will be completely going through the analyzer. Nothing is blocked. So the intensity will be starting with 320 watts per meter square, and then it will be 160 and 160 as well. But right now the analyzer is rotated by an angle of 30 degrees, and the energy will be 100% at first, 50% over here, then it will be less than 50% in the end. And how much is passing through the analyzer? Here we can take the Moller's law. Moller's law is going as this equation. The intensity reaching the analyzer is I0. The I0 here should be 160, just like the one we stated above. 160. And now we are going to take cosine 30 degree square. According to the question, because it's a non-calc paper, cosine 30 degrees square should be square root 3/2 and then square. So the rest is mental math, and it should not be very challenging to get the answer be 120 watts per meter square. Answer is A. Question 16, we have 4 different charges going along the line of x-axis, and they are creating their own electric field. For instance, a positive charge should create a positive outward electric field. And this outward electric field would extend and hit the position of P. We will do the same for all different charges. Q over here is outward and it's going in this direction. But on the left hand side, they are negative charge, so they are creating a negative radially inward field. So it's in this direction. And lastly, for the furthest left is radially inward, so it's going in this direction as well. And you can see that all these electric fields taking place on P, they are kind of pushing to the left, which means the answer should be D. But the full solution of why it's perfectly horizontally going to the left, it's because when you take a look at the red arrow, it's diagonally going to the top left, which means it has a vertical component going up and a horizontal component going to the left. This is going to balance and pair with the orange one. It's diagonally going to the bottom left, so there's a component going to vertically down and horizontally to the left. Those vertical components, they are completely the same because they're in the same distance to the center and they are the same magnitude, negative Q and positive Q. So these two components, they are erased, leaving the horizontal to the left. And this happens to the green and blue as well. So the answer should be perfectly horizontally to the left, D. In question 17, we have two circuits. The first circuit is an ideal cell connected to a working bulb. Let's label the cell giving an EMF epsilon and the bulb carrying a resistance of R. In the second circuit, we have the same battery as a power supply, which means the EMF is the same, epsilon. But there are two identical bulbs, just like the previous one. We have two identical bulbs, each of them carrying R in resistance. Now we're going to study the change in potential difference of one of the bulb. Because in the old circuits, there's only one load in the system, so the PD of this load should be the EMF. But in the new circuits, there are two identical bulbs, then they will be symmetrically and they will be identically taking half of the EMF. So the new PD will be half of epsilon here. The potential difference should be decreased. Next one, the output power of the battery. Power could be IV, could be I square R, could be V square over R. Now we can take power of the bulb add up to be V square over R. And these two bulbs together, they have total being EMF. But their total resistance is 2R now, which means the power output by the battery or the total power gain by the light bulbs is halved. So the answer is A. Question 18, it is a pretty complicated circuit question. So if you need some more help, feel free to leave comments below. Let's take a look at these circuits. This is a one power source but four load circuits. And on the right hand side, you have a voltmeter. Here we can form two complete loops, and both loops, they are enclosing the power supply, namely the red one and the blue one. Because when you put them all together, it's going to make the circuits more complicated. Then let's draw two circuits, both red and blue, over here. The circuits, they are 3 volts, 1 ohm, and 2 ohm for the red. For the blue one, it will be 3 volts being the power supply, and then 2 ohm resistor and 1 ohm resistor in the end. On the left hand side, I'm going to use a green pen to show you the electric potential. Not electric potential difference, is the electric potential only. Starting from the power supply, it should be 3 volts being the electric potential and 0 volts being the electric potential. So they are differed by 3. That's what the electromotive force means, is 3 and 0 differ by 3 volts. Similarly, it will be 3 at the top and 0 at the bottom. Then the question mark is here. What is the electric potential at that point? At that point, we should first study the total voltage and total current and total resistance. Let's put down T as a subscript to remind yourself it is the total value. The total voltage will be 3, total current is unknown, and the total resistance in the red circuit is 1 plus 2, which gives the total current be 1 ampere. And this 1 ampere will pass through the 1 ohm resistor. So we have another V equals IR, with subscript being 111. Voltage is unknown. Current is 1 ampere. Resistance is 1 ohm. So the voltage of the 1 ohm resistor should be 1 volt. The voltage is 1 volt, which means the electric potential value should be dropped by 1 from the 3 volt, which makes it 2 volts. Therefore, the final potential difference between the 2 volt point and the 0 volt point, it is 2 volt. That's how you solve everything in these circuits. And we can put down this information on the circuit above. It's 3 volts here, 3 volts here, 0 volts here, 0 volts here. And on the left junction is 2 volts. And we shall do the same on the blue circuits. On the blue circuits, then you will calculate it is 2 volt here and 1 volt here. For its potential, after a similar calculation, you will see it is 3 volt, 0 volt, 3 volt, 0 volt, and here it is 1 volt. Because from 3 down to 1, it should be dropped by 2. So it is 1 volt here. Now this voltmeter is sandwiched by 2 volt and 1 volt. The potential difference across the voltmeter, it is 2 volt minus 1 volt, which gives 1 volt. B. In question 19, there is a direct current running through the coil. And we can assume the magnetic field is uniform going between the magnets. Because the coil rotation is indicated very clearly, so the force on rod XY must be going upward. And the magnetic field between the magnets must be going from north to south. So using your left-hand rule, you can deduce the currents should be going in this direction, in the green direction. After a certain time later, the loop will be flipped, which means the south pole is still on the left, the north pole is still on the right, but the coil inside is flipped. Then X is over here and Y is on the right as well. And in this case, the current is still driven by the external power supply, which means the current is still going in this direction. And the magnetic field is still determined by the magnets. Okay, time to apply your left-hand rule again on the XY rod. And this time you shall see that the force is going downward, which means the force reverses direction from upward to downward. And option A, B, C, D, only A and D suggest that the force could be reversed. We have positive force and negative force. Positive force and negative force. Next one is the magnitude of the force. The magnitude of the force is determined by this equation, F equals BIL sine theta. B is unchanged, I is unchanged, L is unchanged, and even the angle theta, which is the angle between B and I, is still unchanged. So the magnitude of the force is constant as long as it's inside a uniform magnetic field. The answer should be A.
In question 20, we have a satellite orbiting the Earth. So we have Earth in the center, and then orbiting around it, there is a satellite. And then this satellite is moving at a constant speed, which means right now there is a gravitational force pointing towards the center. And this gravitational force is the resultant force. Option 1 is correct. Other than gravitational force, there is no any other forces else. And for Newton's second law, we have net force equals to ma, and the mass times the gravitational acceleration is the net force in this case. The second statement is correct. Lastly, option 3, the centripetal force is provided by the net force. The net force in this case is the gravitational force. Therefore, Centripetal force is equal to the net force. Meanwhile, gravitational force is equal to the net force. In other words, centripetal force and net force, they are equivalent. Option 3 is correct as well. We pick D here. Question 21, it's about weightlessness. And to be honest, weightlessness is a misleading term. I suggest you take it as normal reactionlessness. Because weight is always acting on a mass in a gravitational field. However, the normal reaction may not be present. For instance, if you are standing on the ground on the earth, then on your body there is a weight and there is a normal reaction. But if you are falling through the sky, if you are having a maybe skydiving, then you will experience a weight, but there is no normal reaction. And this is weightlessness, and my term, normal reactionlessness. What if you are in an elevator and the cable of the elevator is snapped? Then the cage and your body, they are both falling under their own weights. Which means no matter the passenger or the cage of the lift, they are both accelerating under the free fall of gravitational acceleration. And this is causing you no normal reaction. Once again, is weightlessness. And finally, what if you are in a spaceship? Let's say this is a spaceship and you are inside. Then your body and the spaceship all together under the same acceleration of free fall. So the answer is B, because your body experiences no normal reaction and is a result of both the astronauts and the spaceship accelerations. They are the same. In question 22, it begins with some white lights. And this white light is heading towards a gas sample. Let's say this is a jar of gas sample, hydrogen gas. After passing through the gas sample, it is reaching a diffraction grating. And the diffraction grating would cause a diffraction, and these are going to fall onto the screen. Because it begins with white light, so after passing through the grating, the screen should be full of color, which means you can see the rainbow spectrum on the screen. However, it passed through the gas sample first, and in the gas sample, we can see some photons, not all, just specifically some wavelengths of the photon were absorbed. If they were absorbed, which means they will be absent from the screen. And therefore on the screen, there are some absence, black fringes representing those photons being absorbed. And this is going as the background being colored and the lines they are dark. D is our answer. In question 23, we are going to identify which type of fundamental interactions could electrons be experiencing. Let's take a look at what properties does electron carry. Firstly, it has mass. Because it has mass, therefore it should experience gravitational interaction, and graviton could be interacting in it. And also, electron is a lepton. Therefore, weak interaction is possible. W boson and Z boson, they are all possible. Next, electron is charged. So, it should experience electromagnetic interactions, and therefore, virtual photon is one of the mediating particle. However, electron is neither quarks nor gluons. Therefore, there is no strong interaction nor any gluons mediating between electrons. So the answer is statement 1 and 3. We choose B here. In question 24, we can see a nuclear fission. It begins with a neutron being absorbed by uranium-235 nucleus. So let's begin with a equation balance from the left-hand side going to the right-hand side, and it will be uranium-236 nucleus. After that, it's going to split into two daughter nuclei. They are barium-144 and krypton-89. However, if you take a look at these numbers, they don't add up because there is certain number of neutron being emitted as well. So let's focus on the mass number balancing. We have 144 plus 89 plus the unknown number of neutron equals to 236. And the unknown number of electrons is actually 3. In question 25, we have a radioactive nuclide X decays into Y. And it suggests that they share the same nucleon number, which means it must be a beta decay. It could be beta plus or beta minus, we don't know, but it must be something to do with beta decay. Next, we can see that the radioactivity drops significantly. And it was 100% at first, then it will be 50% after 2T. Therefore, 2T is the half-life. So the answer is D. On question 26, we got a very easy peasy one. Here, we're going to identify the energy transfer in a photovoltaic cell and the solar heating panel. It's very clear that the photovoltaic cell, it's definitely related to electrical energy. And it is turning the sunlight into electricity directly. Next one, solar heating panel. It must be something to do with thermal energy. And in fact, it's turning some cold water into some warm and even hot water using solar energy. So the answer is A. In question 27, we are going to give some descriptions on the fossil fuels. Firstly, fossil fuel is definitely a non-renewable energy because the rate of production is much lower than rate of consumption. So statement 1 is correct. Next one, statement 2. For all fossil fuels, there must be a combustion. It would turn some oxygen gas into carbon dioxide, and therefore it is releasing a lot of greenhouse gases. Statement 2 is correct as well. For statement 3, it's also true. The distribution of fossil fuel is definitely not going to be completely even fair to all countries. Those countries having the hands on more fossil fuels, they have more bargaining power. Therefore, we choose D here. Question 28. We know that the age of the Earth is very, very old, over billions of years. And how do we estimate this age of the Earth? The answer is we use radioactive dating. We use carbon dating for those living things, but for the Earth, we don't use carbon dating because carbon dating is quite limited to a very short age, usually not more than 50 or 60,000 years old. With this long age of the Earth, an isotope of much longer half-life is required. However, the answer is definitely C, radioactivity. Question 29. Finally, we reach the AHL contents. Here, we have a simple pendulum with its time period being T. And using your formula sheets, you can see time period of its SHM pendulum, it should be 2 pi L over G in the square root. And now we use the same pendulum on the moon and on the Earth. So the L is a constant, which means right now T is proportional to 1 over square root of G. And when the G is reduced to 1/6, the time period would be root 6 times longer. Then the answer is A. In question 30, you can see a white light is going through a dispersion on the left and a diffraction on the right. In a dispersion, the higher frequency of light should refract more. So the original path was this one. Now, the violet light having a higher frequency and therefore it will refract more from the original wave. And red light would refract less from the original path. So the answer for the first column is red. Next one, on the diffraction grating one, it's going as the equation of d sine theta equals to n lambda. With a greater lambda, there is a greater sine theta and therefore the angle theta as well. Red light gives you a longer wavelength, so P is the red light and Q is the violet light. Which means the answer for column on the right should be red light. Answer is A. In question 31, we have a train sounding its whistle and performing a Doppler effect towards an observer on the station. The observer is being stationary, but the train is moving towards it. And the wavefront created by it would be compressed on the right, which means you can see the spacing between the wavefronts, they are so close, and it indicates the wavelength is shorter. And the wavelength on the left is longer. And this shall be described as the V equals F lambda equation. Wavelength is shorter, but the wave speed is unchanged, so the frequency is higher. Wavelength being shorter, which means statement 2 is wrong, and statement 1 and 3 they are correct. We pick option B. In question 32, we are going to study the electric field at X and the electric potential at X. Let's begin with the red teaching, electric field. The electric field at X is a result of 4 charges on the corner. A positive charge should generate an outward field. Therefore, it will be going to the bottom right and top left according to the positive charges. And it will be going radially inward because of the negative charges in the corner. And you can see that it is a square, they are in equal distance and they have equal magnitude. Therefore, all these electric fields, they are balanced, they are cancelled by each other. Then the electric field at X should be 0. And next, electric potential. Electric potential could be positive, could be negative, and this is a scalar quantity. You don't need to study its direction. Positive charge will give you a positive potential. Negative charge will give you a negative potential at X. And once again, is a square, is equal distance, is equal charge, everything is the same. So they are balanced. And same to the other charges on the other corner. It could be negative potential and positive potential, but they're the same magnitude, so they are crossed out. Which means the electric potential at X is once again 0. And the final answer is A. In question 32, you are given with a graph of electric potential and its variation with distance r. And this is clearly going as the electric potential gradient equation, which is electric field strength equals to negative delta VE over delta R. And this is the gradient of the graph, which means the electric field strength is the negative gradient of the graph. The answer is D. In question 34, we are going to study briefly the operation of a transformer. In a transformer, there's a primary coil on the left and there's a secondary coil on the right. Those components in green, they are carrying electricity, which means between the primary and the secondary, there is no electrical connections. And what's going through them is the magnetic flux linkage. Therefore, there is no electrical connections between the primary and the secondary coil. And there is a magnetic interaction between the primary and the secondary. Also, the power supply here must be a AC supply. Using a DC being the supply, it won't work. And the detail shall be go over in some other teaching. Here, the short answer is alternating currents being the input, and the answer is B. In question 35, we are going to study the Fleming left-hand rule adding on an electron moving with the metal bar. The metal bar is moving downward, which means those electrons, they are moving downward as well. And as the electron, they are moving down, is generating a current going up. So using your Fleming left-hand rule, you have your middle finger going upward. And the magnetic field is going into page, which means your index finger should be going into page. Then your thumb should be pointing to the left, which means all these electrons, they are forced to the side of PS. With the QS, they are lack of electron. And the answer is D. In question 36, here I'm going to give you a very special exam tips here. Those regions in red, they are known as dielectric, which means they are insulator. Then the charges, they are confined inside this isolated island. Just like in the middle of the sea, nowhere else to go. Charges in this island, they're only able to be redistributed to the Z, to the X, or to the Y. Take a look at the power supply. It is negative on the left and positive on the right, which means electrons are drawn in anticlockwise. If the XY side is losing 4 electrons, which means on the Z plate is gaining 4 electrons. And X, Y, they are actually two separated plates, which means X should be losing 2 electrons and Y is losing 2 electrons. Then let's focus on X and Z. X and Z, they are in a ratio of 1 to 2. So the answer is 1 to 2. C is the correct answer. In question 37, we are going to identify which of the following observation is a result of the wave-like property or the particle-like properties of electrons. Statement 1, electron beam is used to investigate the structure of crystals, and this is done by electron diffraction. Diffraction is a wave property, so statement 1 is correct. Statement 2, the electron beam is passing through 2 narrow parallel slits and therefore once again diffract. So it is another diffraction, another wave-like properties demonstration. And the last one is electrons are being ejected from a metal surface upon the incidence of light, and this is considered as photon falling onto the metal surface, and it is a particle-like properties of electrons. So the correct answer is 1 and 2, option A. Question 38, we have two different nuclides, X and Y, and the number of X and number of Y is going in this ratio. X to Y is 1 to 2. The half-life of nuclide X to half-life of nuclide Y is 2 to 1. And this is the ratio of their decay constant. So let's bring these two ratios into action. And what do we do with these? We check the formula sheet. You should be given with these two equations on the right. The part over here and the second row, they're completely the same, which means you can merge them together and you shall obtain this equation. Next, you can take it into ratio, which is activity of X to activity of Y is equal to lambda X over lambda Y and nx over ny. From the previous work on the left, we can tell lambda x to lambda y is 1 to 2, and x to ny is 1 to 2 as well. So the final answer is 1 to 4, A. Question 39 is a question of photoelectric effects. Photoelectric effects, usually we begin with this equation. This Greek letter it is the work function of the metal. Ek is the kinetic energy of the photoelectron removed from the metal surface. And it is actually y equals mx plus c, which means if you extend the graph, then you should be able to see a y-intercept. And the y-intercept is negative work function, with its gradient being h, the Planck constant, is always same value. In other words, B and C, they must be wrong, as they give a different gradient. Next one is A or D. Which one gives you a correct answer? You can see that option A is giving you a smaller work function. Is the question looking for a new metal surface in which there is a smaller work function? Let's take a look at this sentence. The new metal surface is requiring less energy to remove an electron from the metal surface. Therefore, we are looking for a lower work function, and the answer is A. Question 40, it is about the wave function. And the wave function delta V is stands for a certain volume. It's something to do with coordinates and places. So it has nothing to vary with the time. And then comparing A and C, you can see that one of which is only going on the positive side, the other one is going in positive and negative varying. And as you check the y-axis title, it is an absolute value as well as squared value. There is no chance you can get any negative number. So the answer is C, always positive. This is the end of the solution video. Feel free to leave some comments below, and I will see you next time.